Your EcoBoost turbocharger spins at 2,500 revolutions per second on an oil film thinner than a red blood cell. Yet, every single freezing morning, you are likely doing something that completely cuts off that vital lubrication. I have spent 15 years tearing down failed Ford engines. I have sliced open dozens of ruined EcoBoost turbos. They all tell the exact same story. They show catastrophic bearing destruction that started the very second the owner turned the ignition key. The manufacturer tells you to just start up and drive. They build trucks with automated remote start systems that encourage extended idling. They sell you a lie of convenience. Today, I am exposing the hidden flaws in these manufacturer defaults. I am breaking down the exact habits that are quietly melting your turbo. Let us start with the single most common mistake. It is an error almost every truck owner makes on a freezing winter morning. Setting 7. Mashing the throttle within 30 seconds of a cold start. You are running late for work. You fire up your truck, shift into drive, and immediately floor it to merge into fast traffic. You think the engine can handle it because the dashboard isn't lighting up with warnings. You are completely wrong. This single 30-second choice causes more severe metal-on-metal damage than months of hard highway driving. Here is the mechanical reality inside your engine. When your vehicle sits overnight, gravity pulls the engine oil out of the turbo housing. The fluid drains completely down into the bottom oil pan. The delicate journal bearings are left completely dry. When you crank the engine, the oil pump must force cold, thick lubricant through narrow, restrictive feed lines. In freezing temperatures, motor oil moves with the consistency of molasses. The delay before full oil pressure reaches the turbo can take several critical seconds. Now consider what happens when you demand heavy power during those exact seconds. The turbocharger instantly receives a massive blast of scorching exhaust gas. The turbine wheel accelerates toward 100,000 RPM in the blink of an eye. The internal shaft spins at astronomical speeds while the bearings have zero fluid protection. That is direct metal-to-metal friction at speeds the components cannot survive. Engine builders know that running a turbo dry for 5 seconds causes as much localized wear as running an entire engine without oil for 5 minutes. The turbo bearings are the most vulnerable components under your hood. They spin faster and run hotter than any piston or crankshaft. They fail first when lubrication lags. I have disassembled turbos from EcoBoost trucks with under 70,000 miles on the odometer. The internal journal bearings always show distinct blue and bronze heat discoloration. That tempering color means the metal reached temperatures over 500 degrees Fahrenheit. The owners had no idea this was happening. The truck still drove down the road. It just suffered a slight loss in boost efficiency and a faint whistling sound the driver ignored. A replacement turbocharger assembly will cost you over $3,000 in parts and labor. The mechanical solution costs you absolutely nothing but 30 seconds of patience. The fix is simple. After every cold start, let the engine idle for 20 seconds before moving. Then, drive gently for the first 3 miles. Keep your engine speed under 2,500 RPM. Stay completely out of heavy boost until the temperature needle actively moves away from the cold mark. You are not babying the machine for no reason. You are giving the thick oil time to fill the lines, thin out, and create a protective hydrodynamic barrier. Setting 6. Shutting the engine off the exact second you park. This habit is the evil twin of the cold start mistake. It creates hidden damage that destroys your lubrication system during the next morning's start. When you drive a turbocharged vehicle up a steep grade or accelerate hard on the highway, the turbine housing gets blistering hot. Exhaust gas temperatures frequently exceed 900 degrees. The oil flowing through the center cartridge acts as a cooling agent, carrying that extreme heat away. When you pull into a parking spot and immediately shut off the key, the oil pump stops instantly. The fluid stops moving, but the turbocharger housing is still radiating immense heat. The stagnant oil sitting inside the hot bearing passages literally cooks. The intense heat bakes the static oil into hard carbon crust. Technicians call this destructive chemical process coking. Here is how this ruinous process directly connects to your next cold start. Those hard carbon deposits build up inside the tiny oil feed lines that supply the turbocharger. Over months of hot shutdowns, the internal diameter of the oil line chokes down. The passage becomes restricted. The next freezing morning, your turbo desperately needs immediate oil delivery. But the supply route is partially blocked by baked carbon. You have created a lethal double whammy. Cold, thick oil is now struggling to pass through a restricted, clogged tube. The bearings starve for double the normal time. An OEM oil feed line replacement is a tedious $500 job. Waiting a moment in your driveway costs $0. The fix is straightforward. Idle your engine for 45 seconds before turning the key off after any highway cruise or heavy acceleration. This brief idle keeps the oil circulating. The moving fluid pulls the peak heat out of the metal housing and drops the temperature to a safe zone before the flow stops. Setting 5. Running the wrong oil viscosity or pushing past the drain interval. Your owner's manual specifies a specific oil weight for a critical reason. On modern turbocharged engines, that fluid specification is chosen specifically to combat cold start starvation. The first number in an oil rating represents the cold flow characteristics. A 5W30 synthetic fluid flows exponentially faster in sub-zero weather than a 10W30 conventional oil. If a generic quick lube shop puts a heavier oil in your engine because they believe thicker oil protects better, they have compromised your turbo. Thicker, cold oil takes significantly longer to climb the engine block and reach the upper turbo lines. That is the exact opposite of what your engine needs on a winter morning. An even bigger crisis is running engine oil past its operational lifespan. Modern direct injection engines suffer from a known mechanical issue called fuel dilution. Gore fuel washes past the piston rings and mixes directly into the crankcase oil. This fuel contamination thins the oil and breaks down the protective film strength. Degraded, fuel-diluted oil cannot maintain the micro-thin fluid barrier the turbo shaft requires. Furthermore, the suspended contaminants begin to plug the oil screen filters. Statistically, 50% of all premature turbocharger failures stem directly from oil quality issues. This means half of these expensive repairs are completely preventable. A premium full synthetic oil change costs $70. A seized turbocharger that sends metal debris into your intake can cause a $10,000 genuine replacement. The fix is non-negotiable. Use only the exact viscosity rating specified by the factory. Switch exclusively to a high-quality full synthetic fluid. Change that oil every 5,000 miles or 6 months. Do not follow the optimistic 10,000-mile oil monitor on your dashboard if you care about your turbocharger. Setting 4. Prolonged cold idling to warm up the vehicle cabin. This habit feels like the responsible choice. Owners believe they are being kind to the mechanical components by letting the truck sit in the driveway for 20 minutes. In reality, you are subjecting the engine to a prolonged period of low lubrication stress at a warm-up idle. Your engine oil pressure drops to its lowest operating specification. Yet, the oil remains cold and highly viscous because an engine generates very little heat without a driving load. Your turbo bearings are left sitting in sluggish oil at minimal pressure for 20 minutes straight. Worse yet, extended idling causes incomplete combustion. Unburned fuel washes down the cylinder walls, dilutes the oil film, and speeds up the degradation of the lubricant. There is also an aerodynamic problem at play. When the turbo spins slowly at idle, it creates a pressure imbalance across the internal seals. Oil begins to seep past the seals and enters the exhaust housing, leading to oil consumption and carbon buildup on the turbine blades. The fix requires changing your morning routine. Modern fuel-injected engines do not require extended idling. Start the vehicle. Wait 30 seconds for the oil pressure to stabilize across the system. Then, drive away using light throttle inputs. Driving the vehicle puts a load on the engine, which brings the coolant and oil up to proper operating temperature 4 times faster than idling. The fluid thins out and reaches maximum protective efficiency much sooner. If you must use remote start, limit the run time to a maximum of 5 minutes. You might think these 4 habits are bad enough, but the mechanical abuse gets significantly worse as we look at how drivers interact with their instrumentation. Setting 3. Blinding yourself to the real-time data on your dashboard. Your truck is actively measuring the exact parameters that dictate whether your turbocharger survives or self-destructs. Yet, you are likely treating your instrument cluster like a decoration. Most drivers use the temperature gauge on the dash for one thing, checking if the engine is overheating. They only look at it when steam is pouring from the hood. This is a critical oversight. The cold side of that needle is actually the most important sector for component longevity. When you start your vehicle on a freezing morning and that needle is resting dead on the C mark, your oil is thick, sluggish, and incapable of forming a stable hydrodynamic film. Your turbocharger is at its absolute maximum vulnerability. Here is the engineering reality. Inside that turbo, the steel shaft rides inside brass or bronze journal bearings. The clearance between the spinning shaft and the bearing wall is microscopic, frequently measuring less than 0.001 inches. To keep metal from tearing into metal at 150,000 RPM, the engine oil must be hot enough and thin enough to be forced into that tiny clearance under high pressure. When the oil is cold, its viscosity prevents it from shearing and flowing into that microscopic gap efficiently. If you ask for boost while that needle is cold, you are forcing the shaft to spin at high velocity with a compromised oil barrier. The resulting friction causes localized thermal expansion. The shaft swells, rubs directly against the bearing, and begins the process of galling and catastrophic failure. On higher trim Ford models, you can configure the digital dash to display actual live oil pressure numbers. On a freezing morning, you will see that cold oil pressure spike incredibly high, sometimes over 80 psi at idle. Many owners see high pressure and think, great, plenty of lubrication. They are wrong. High pressure with cold oil means high resistance to flow. The oil pump is struggling to push that cold sludge through the engine block. The pressure is high at the sensor, but the actual fluid velocity inside the turbofeed line is dangerously low. Ignoring these gauges and replacing a destroyed engine block because a seized turbo snapped its shaft and sent metal shrapnel directly into the cylinders will easily cost you $12,000. Paying attention to your dashboard costs you nothing. The fix is a strict behavioral discipline. Make it an absolute habit to look at your temperature gauge before you pull away. If the needle is on the cold mark, you do not cross 2,000 RPM, and you do not apply more than 25% throttle. You stay completely out of the boost threshold until that needle climbs into the normal operating range. Setting 2. Revving the engine on a cold start to speed up the warm-up process. This is the absolute king of destructive habits. It has single-handedly sent more EcoBoost trucks to the scrap heap than any factory casting defect ever could. The cruel irony is that drivers usually do this believing they are helping the machine. The misguided logic goes like this. The truck is freezing. The engine is idling rough. So you tap or hold the throttle to get the RPMs up to generate some quick heat. What you are actually doing is launching a weapon directly at your turbocharger bearings at the exact microsecond they are completely dry. Let us revisit the cold start timeline. When your engine sits for 8 hours, the oil drains completely out of the turbo housing back into the oil pan. The moment the starter motor turns the crankshaft, the turbo bearings are running on nothing but a residual, microscopic film left over from the day before. The oil pump requires roughly 3 to 5 seconds just to pressurize the main oil gallery, and another 3 to 5 seconds to force that thick, cold fluid up the vertical feed lines to the top of the engine where the turbochargers reside. When you rev the engine during this specific 10-second window, you send a massive, high-velocity pulse of hot exhaust gas directly into the turbine wheel. The turbocharger doesn't just rev up mildly. Its lightweight wheels rocket toward 80,000 to 100,000 RPM instantly. You are now spinning a metal shaft at astronomical speeds inside dry metal bearings with zero pressurized oil delivery. The intense friction creates an instantaneous spike in localized heat. This causes immediate metal transfer, where molecules of the brass bearing literally melt and weld themselves onto the steel turbo shaft. The shaft develops deep scoring, destroys its own balance, and begins to wobble. Once a turboshaft develops axial or radial play, total failure is only days away. A set of upgraded replacement turbochargers and lines will run you roughly $4,500 at a reputable independent shop. Keeping your foot completely off the gas pedal during startup is entirely free. The fix is absolute. Never touch the accelerator pedal when starting a modern turbocharged vehicle. Keep your foot firmly on the brake, press the start button, and let the computer manage the high idle strategy. Do not touch the throttle until the engine naturally drops down to its base idle speed, and the oil pressure has fully stabilized across the entire mechanical assembly. Setting 1. Using your vehicle exclusively for short, cold trips that never allow the system to reach thermal equilibrium. This is the ultimate silent killer of turbochargers because it doesn't feel like abuse. There is no roaring engine, no aggressive driving, and no smoke. It is just the daily routine of driving 3 minutes to the local market, turning the truck off, and driving 3 minutes back home. When you chain these short trips together, day after day, you are systematically poisoning the very fluid that your turbocharger relies on to survive. On direct injection EcoBoost engines, the fuel injectors spray gasoline at extreme pressures directly into the combustion chamber. When the engine block and cylinder walls are ice cold, a small amount of that atomized fuel fails to ignite. Instead, it condenses back into liquid on the cold cylinder walls and gets scraped down into the oil pan by the piston rings. During a normal highway drive, this injected fuel contamination isn't an issue. Once the engine oil reaches its full operating temperature of around 212 degrees Fahrenheit, the volatile fuel and water moisture mixed into the oil safely evaporate out through the PCV system. But on a 5-minute drive, your engine oil never gets hot. It barely cracks 100 degrees. The fuel and moisture remain trapped in the oil pan. Trip after trip, the raw fuel accumulates, causing severe fuel dilution. Over a few months of short trip driving, your 5W30 motor oil can be diluted so heavily by raw gasoline that its viscosity drops down to the equivalent of a 0W16 or worse. Gasoline is a solvent, not a lubricant. It strips away the boundary layer protection inside the turbocharger's journal bearings. The next time you start the truck, the turbo shaft is spinning on a diluted mixture of oil and fuel that cannot support the load. The metal surfaces grind together, wearing down the tight tolerances until the compressor wheel shifts and slams into the aluminum housing. Ignoring this short trip reality means you are driving a ticking time bomb. A premium oil analysis costs $40 and will prove this contamination exists. Ignoring it guarantees a multi-$1,000 turbo teardown. The fix requires a fundamental shift in how you maintain and operate your vehicle. If your lifestyle dictates short commutes, you must cut your oil change intervals in half. Do not wait for the dashboard reminder. Change your full synthetic oil every 3,000 miles maximum. Additionally, you must take the vehicle on a thermal Italian tune-up at least once a week. Drive the truck on the highway for a minimum of 30 continuous minutes at sustained speeds. This forces the engine oil up to full operating temperature, long enough to boil off the accumulated water and raw fuel, restoring the chemical integrity of the lubricant before it eats your bearings alive. While these 7 habits represent the hidden operational traps that most owners fall into, the actual physical components under the hood possess their own built-in design flaws that compound these issues dramatically. The design engineers at the factory know exactly how vulnerable these engines are. They write specifications to survive the warranty period, not to make your truck a 300,000-mile machine. If you want your vehicle to last, you have to stop trusting passive manufacturer logic and actively defend your oil supply. This brings us to the ultimate, most deceptive mechanism of destruction. It is a hidden design feature that was sold to you as an emission-saving benefit, but it acts as a silent executioner for your turbocharger bearings. The absolute worst cold start danger is relying on the factory auto stop default configuration during winter conditions. You pull out of your driveway on a freezing morning. You followed the rules. You waited 30 seconds, and you are driving gently. But 2 minutes down the road, you come to a complete stop at a red light. The dashboard tells you the coolant is still ice cold. Yet, the factory auto start-stop programming instantly shuts the engine off to save a micro drop of fuel. You think nothing of it. The light turns green, you step on the gas, the engine fires back up, and you continue driving. You have no idea that the factory logic just subjected your freezing turbocharger to another dry startup cycle. Let us look at the internal fluid dynamics. When the engine drops to 0 RPM at that traffic light, the oil pressure drops to absolute zero instantly. Because the engine oil is still cold and thick, it does not hold an even residual film. It immediately slumps back down out of the elevated turbo feed lines. The moment you lift your foot off the brake to accelerate, the starter motor cranks the engine and the fuel injectors fire. But the engine computer does not wait for oil pressure to build before it commands exhaust energy. The engine instantly revs to welting 500 RPM to pull the truck away from the intersection. The sudden rush of exhaust gas slams into the turbine wheel, spinning the turbo up to speed before the cold. Thick oil can travel back up the empty feed lines. Every single stop-and-start sequence on a cold morning multiplies the number of dry bearing contacts your turbo suffers by the time you reach your office. A drive that should have involved exactly one cold start has now subjected your turbocharger to 6 separate oil starvation events. The manufacturer programmed this behavior to meet strict federal fleet fuel economy standards. They traded the microscopic clearance tolerances of your turbocharger bearings for a fractional increase in window sticker miles per gallon. Allowing this cycle to repeat every winter morning will systematically wear down the journal bearings until the compressor blades develop play and destroy the housing. A replacement EcoBoost turbocharger unit costs up to $3,500. A high-quality aftermarket auto start-stop disabler plug costs roughly $90. Pressing the factory disable button costs absolutely nothing. The fix is immediate. By disabling the auto start-stop system, the very first thing you do every single time you start your vehicle on a cold day. Do not allow the engine computer to kill the oil pressure while your oil temperature is below normal operating thresholds. Keep the oil pump spinning continuously so a steady stream of pressurized oil is constantly forced through the turbo cartridge. Let us summarize the mandatory survival rules for your turbocharged engine. The entire lifespan of your turbo comes down to basic fluid discipline, the 30-second rule. Never shift into gear immediately after a cold start. Give the oil pump time to push thick oil up to the elevated turbo lines, the warm-up threshold. Keep your engine speed below 2,500 RPM and stay out of boost until your temperature needle moves off the cold mark, the idle down habit. Never kill the ignition immediately after highway speeds or heavy acceleration. Allow the engine to idle for 45 seconds to pull extreme heat out of the turbine housing. The oil discipline. Throw away the factory 10,000-mile oil change interval. Change your full synthetic oil every 5,000 miles maximum to prevent fuel dilution from eating your bearings. The manufacturing defaults are engineered to get your vehicle past the dealership warranty window and straight into the service bay for high-dollar component replacements. If you continue to eat a modern turbocharged engine like a basic, naturally aspirated machine, you are actively paying for its destruction. Take control of your operating habits. Protect your investment.